Well, here we are. It's the final boss of the equation solving unit. If we can handle this, we can handle just about anything. This doesn't equal zero or anything else, so we're not going to have to solve it. The challenge is simply to factor it, and that's going to be plenty anyway. So, just like we start every other problem, we ask, does this have any common factors? And there are a couple of things. The coefficients both have ninths in them, so we should be able to factor out a 1/9. And also, the first term contains 4x minus 3 to the minus 2/3. The second term also contains 4x minus 3. Different power, but we can probably do something with that anyway. So let's get a 1/9 out of there. You could take out the 1/9 and the 4x minus 3 in one big step. I'm going to do it as two small steps because we're just learning. And let's see what's left after this. Minus 4/9 divided by 1/9 leaves us with minus 4. And everything else in that term stays put for now. Plus 5/9 divided by 1/9 leaves just 5. And then we have the 7x plus 1 and 4x minus 3 to the 1/3. Okay, so that's a little bit better. The other common factor I mentioned was the 4x minus 3, and the lowest power of it is minus 2/3, so this is coming out. We have our 1/9, that just sits there. We take out 4x minus 3 to the minus 2/3, and let's see what remains after that. We have minus 4. Well, this just vanishes, because we have 4x minus 3 to the minus 2/3 divided by exactly the same thing. In our next term, we have a 5, we have 7x plus 1, and we're going to have 4x minus 3, but to what power? 1/3 minus negative 2/3, because we're dividing by it, is the same as 1/3 plus 2/3, which is 3/3. That reduces, which I'm going to be happy to do in the next line. Let's see what we get now. 1/9, 4x minus 3 to the minus 2/3, minus 4 plus 5 times 7x plus 1 times, it's 4x minus 3 to the power of 1, so I'm not even going to write it. I'm just going to say 4x minus 3. All right. Now, the thing to do when you have brackets like this with a number of different factors inside them is actually to expand this, which feels weird when we're trying to factor, but if we expand this and collect like terms, we may get something that has more common factors hiding in it. Right now, this doesn't have any common factors, but there might be some if we multiply it out and recombine. So let's see what we get out of that. This is not something that's guaranteed to work, but it's about the only thing left to try when you get a big jumble like this inside brackets. So we have minus 4 plus 5 times, now I'm foiling these two, 7x times 4x is 28x. I started to say 140 because I'm thinking ahead to what this 5 is going to do, but let's not get ahead of ourselves. Outside, we get minus 21, that's x squared. This is minus 21x plus 4x and minus 3. And write this again. It's a little tedious rewriting all of this over and over again, but the alternative is trying to remember all the pieces, leaving pieces behind, and then hoping that you remember to bring them forward at the end. I see people mess that up all the time. I just don't like it. I would rather take the extra time to write this out and be consistent about it for the sake of keeping errors down. So 5 times 28, there's my 140x squared that I was so excited about. Here we're going to get minus 21x plus 4x is minus 17x. Multiply that by 5 and you get minus 85x. And 5 times minus 3 is minus 15. Okay, we can clean that up and fix the order. 4x minus 3 to the minus 2/3 times 140x squared minus 85x minus 4 minus 15 is minus 19. And there we are. Now, as far as I can tell, that quadratic is not factorable, and so it doesn't contain any rational roots. So as far as factoring goes, I believe this is the end of the line. If you find that you are able to factor this, please let me or the instructor know. We'd be interested to hear about it. But as far as factoring, this is the best we can do.